So we're going to talk a little bit about relations and functions, what the difference is, and how we can tell depending on what representation we are dealing with. So let's take a look at some information here. This is a definition of relation. It is any set of ordered pairs comparing two things, and you've got an input and an output. Review from past math classes. So any two things compared with one another, that can be called a relation. It's very general. But a function in particular has a particular criteria. Every input has to have only one output. So when you're dealing with any one x, it can only go to one y. That's what makes something a function. So let's go ahead and take a look at these. If you want to pause the video and try for yourself. Otherwise, I'm going to go through each of these one at a time and just review with you whether or not it is a function. So I will circle it in green if it is and cross it out in pink if it's not. So first one. If we are looking at a graph, if you recall, we use something called the vertical line test, and it means if you scan it across, I'm going to use this ruler. If I scan across and it only touches once, then it is a function. Even though it looks like it might kind of conflict right there, one is a circle and one is filled in. So this one's okay. This one's a function. Okay. This one here, this is what we call mapping. So I checked each of my x's. They can only go to one y. So this one right here is being mapped to 2 and to 1. That's a conflict right there. That one is not a function. Okay. In this one, it could be a table and have information rather than just numbers, x's and y's. This one looks like regions, and it's being mapped to percentages. So these are like my x's and this is my y's. If I look here at my list, every single one of these is unique. Even though some of them are very similar, any one x only has one percentage. Notice I don't need to look at the y's. It doesn't matter if those repeat. But if you have an x that repeats and goes to different y's, then that's the problem. So this one is okay. Back to a graph. This one, if I use the vertical line test, it completely fails. There's several places where one x will actually generate two y's. So that one is a no. Okay. And lastly, a table that just has numbers. So if I look here, I can see that we've got two different x values of 4. And they are going to different y's. That is a no-no. This is not a function. You can't have one x that has two different y's. Okay? Now, something new that we're extending is what about equations? You probably haven't dealt with those as much in the past. So when we look at equations, the way we kind of test whether any one x would have more than one y, imagine plugging in a number for x sometimes. So for this first one, if I can pick an x value, it gets squared. There's only one value that I'm going to get once you square that number. This one is a yes. And the key that I want you to think about is that in any equation, if it's y equals and it's just stuff over here, those are all going to be okay. We call that being written explicitly, and those are functions. So if you imagine being able to type it into your graphing calculator, that's another way. If it's y equals and that's it, then it is a function. Okay? Now this one here, it is not solved for y. What you could do is you could solve for y, or if you imagine plugging in an x value, if you imagine here, like let's say I plugged in 0 for x, I'm going to get 4 minus y squared equals 0, or y squared equals 4. Now, if I were to square root this, or imagine just numbers that would work, I can have a negative or a positive too, and square it, and it would give me 4. That means that for one x value of 4, I'm getting two different y's. This is a no. The key to remember in this one, if you ever have something that's not written explicitly, not in y equals, and you see anywhere in there, if it's y squared or any other power that's even of y, then it's a no. Okay? Last but not least on this one is y equals, which you might think, hey, that's okay. But immediately I'm putting a plus or minus. That means no matter what I pick for x, let me pick 0 for x, I'm going to get plus or minus the square root of 1. I'm getting two different y's for any one x I give. So this is a no as well. So the key to remember in the equations, the two main things that kind of ruin functions is y to even power and y equals plus or minus. So that's what I kind of want to put down here. As you look at the different representations of functions and how to tell if it's a function, we want to, let's review these real quick. For a graph, you use the vertical line test. You can write it out, but I'm just going to abbreviate. If you're dealing with a table or a set of ordered pairs, you're looking for repeating x's. That's what ruins it. Okay? So what ruins the function is repeating x's. What ruins it in an equation is y equals plus or minus. That's a no-no. Or if you have y squared y to the fourth, y to the sixth, etc. And again, that's what ruins a function. Okay? So it's important that you be able to take a look at something no matter what form it's in, whether it's a mapping or a table or a graph or an equation, and you can be able to determine if it's a function.